students, welcome to the second part of the chapter number 2, that is on the power plant of the 2 and 3 wheelers. For the power plant of 2 and 3 wheelers, in the previous video we saw about the working of the 2-stroke petrol engine. Whenever we will talk about the 2-wheelers and 3-wheelers, we will always talk about the petrol engine, because diesel engines are very rarely used in the 2 and 3 wheelers. So we will only see about the petrol engines in case of the 2 and 3 wheeler vehicles. So next we will see about the pot timing diagram that is been required for the 2-stroke petrol engine. We saw about the working of the 2-stroke engine, but how the pots are opened in the 2-stroke engine is necessary. Right, the timing at which the pot, that is transfer pot, exhaust pot and inlet pot, we are using 3 pots in case of the 2-stroke engine. So when these pots are being opened and closed is very important for the working of the 2-stroke engine and for the better performance of the engine. So let's see one diagram, that is the pot timing diagram for the 2-stroke petrol engine. Whenever we are saying the word pot timing diagram, which means that we are mentioning the 2-stroke engine. Whenever we will see about the 4-stroke engine, that diagram will be called as a valve timing diagram. Right? This is a basic difference between 2-stroke and 4-stroke engine. Whenever we are talking about the valves, then we are talking about the 4-stroke engine. But whenever we are talking about the pot, then we are talking about the 2-stroke engine. So you can see the diagram which shows you the pot timing diagram, in which you are seeing the 2-stroke that being happening in the engine. Mainly there are 4 processes that happens in the engine, that is suction, compression, expansion and exhaust. We have only 2 strokes to complete these 4 processes in case of the 2-stroke engine. So in case of the 2-stroke engine, the suction and compression happens in 1 stroke, and after that the expansion and exhaust happens in the 2nd stroke. Right. Also you can see the graph or the diagram in which you can see the total 2-stroke engine, how it works and when the valves being opened. You can see the denomination that shows you EPO and TPO at the bottom right side of the diagram, right, which shows you the exhaust port open time, and the bottom one shows you the transfer port open time. In the case of the 2-stroke engine, the charge, that is fuel plus air, is being inserted by the help of the inlet port. From the inlet port, charge comes below the piston, right? That is the difference in case of the 2-stroke engine that we saw in the previous video, right? So charge comes below the piston, it gets compressed, and after charge gets compressed, it is being inserted above the piston with the help of transfer port. So when the charge comes in the engine by the help of the transfer port, the transfer port supplies the charge in the upper part of the piston. That will happen just before the BDC. Generally, in case of the theoretical manner, we open the transfer port when the piston at the BDC, which is at the bottom dead center. But in the actual case, the charge has to be entered before the before the BDC. Right. So charge will be entered in the engine some degrees of the crank rotation before the BDC. After that, for some time, that transfer port will remain open until the charge that is required for the engine fuel burning is being entered into the engine. So transfer port will be closed after some time of the crank rotation, after the piston has moved towards TDC from the BDC. Next we will see about the exhaust port. You can see the exhaust port is open for the more crank angle rotations compared to the transfer port, because in the 2-stroke engine both the valves, transfer port and exhaust ports, are being opened simultaneously, which means that from one end the charge is getting entered and from the other end the charge that is being burned is getting exhausted. So in the two-stroke engine, the main important process that has to be required is the scavenging process. Without the scavenging process, the situation will arise in that the fresh charge can go out with the exhaust charges. So what we are doing is that we are taking the charge from the inlet valve. After that, I have said earlier as well that inlet charge will be compressed in the below part of the piston. After compressing the charge, we are transferring the charge from the transfer port towards the engine. So when we are transferring the inlet charge via the transfer port, it is being compressed. It has a higher pressure. So because of the higher pressure, what inlet charge will do is that it will push out the exhaust charges because of the higher pressure that it has attained because of the compression below the piston. So with this easy method, the scavenging will be possible in the two-stroke engine, and the valve overlapping is very much significant in the case of the two-stroke engine. This process of the scavenging is very important. So in this case, you can see a simple graph of the bar timing. Let's see one another graph of the same bar timing diagram with the angles being shown in them. Right. So in the screen right now, you can see the bar timing diagram with the actual angles which are used when the transfer port and exhaust port opens and closes. So in this graph, you can see that the transfer port is being opened before 35-degree crank rotation of the piston BDC, which means when piston is coming from TDC to BDC, before 35-degree rotation, the transfer port is open. Same after 35 degrees of the piston BDC, which means when piston is going from BDC to TDC, after 35 degrees, the transfer port is being closed. So almost for the 70-degree crank rotation, the transfer port remains open, which is a sufficient time to take the fresh charge into the engine. Now if we look at the exhaust port, in that case 43 degrees before BDC and 43 degrees after BDC will be the total duration of the exhaust port opening and closing. So that will be 86 degrees of the total rotation. As I said earlier, that exhaust port will remain for the more time. You can see the 70 degrees when the transfer port is being opened. Exhaust port is also open. So at that place, scavenging process will be important. One thing also you can see is that the ignition, right? See at the top left side, the ignition, which means the spark in the two-stroke petrol engine, will be given before 20 degrees of the TDC, which means actually theoretically the spark should be given after the compression process, but in the actual case we give the spark earlier, which is known as spark advance. Why the spark advance is necessary is that because when we apply the spark, the burning of the fuel takes a little bit of time. So if we don't give the spark advance, then we will not get the required energy at the required time. When we give the spark advance before 20 degree of the TDC, when the piston reaches at the TDC, the fuel will start burning. So we will get the energy that is required to take the piston down from the TDC to BDC, and we can utilize the power 100%. Right. So this is the port timing diagram that is being used for the two-stroke petrol engine. Now let's discuss about the four-stroke petrol engine. You can see the engine and the components of the engine, that is from piston to connecting rod, crankshaft, fuel injector. Right? This is a basic fuel injector which is being used in place of the carburetor. Earlier we were using the carburetor for the four-stroke petrol engine, which was used to mix the air plus petrol, and then it supplies. But in case of the newer versions, we are using the fuel injector, which injects the fuel in the manifold, and in that manifold the air and fuel gets mixed, and from that manifold the valve takes the charge in the engine. So we do not require the carburetor nowadays in case of the two-stroke vehicles as well, in case of the four-stroke vehicles as well, and in case of the two-wheelers now as well. Whenever we are starting using the BS6 compliant vehicles, we are using the fuel injectors, because otherwise the emission norms does not match. So fuel injectors are necessary in the two-wheelers as well. In the case of the four-stroke petrol engine, there are mainly four strokes that we discussed in the two-stroke engine, that is suction, compression, expansion and exhaust stroke. Now all these four strokes will happen differently, right? In the two-stroke engine we had to complete these four processes in just two strokes, but we have time in this, so the engine will rotate for the two crank angle rotations, and in that two crank angle rotations we need to complete the four strokes that is being used in the engine. The first you can see right now is the intake stroke, in which the air and fuel comes via the inlet valve. After the inlet stroke, or we can say the suction stroke, is completed, the suction stroke will happen when piston goes down. After piston comes down, when piston goes from BDC to TDC again, the compression of the charge will happen. Charge, which means fuel plus air. After the compression processor, the spark will be given with the help of the spark plug, which will provide the burning to the petrol and air mixture. After completion of the compression process, because of the spark and burning of the fuel, the energy will be liberated. That energy will be used for the expansion stroke, or we can say power stroke. Power stroke, because in that stroke the power is generated. And the last one is the exhaust stroke. In the case of the exhaust stroke, the gases that was burned during the power stroke or during the burning of the fuel gases will be exempted from the engine with the help of the exhaust valve. So these are basic four strokes that has been used in the four-stroke petrol engine. Let's see another example of the four strokes that happens in the engine. First one is the suction stroke, which you can see on the screen. In the case of the suction stroke, the inlet valve opens. When the inlet valve opens, the mixture, that is air plus fuel, that is air plus petrol, goes into the engine. You can see also an actual PV diagram of the engine. After completion of the suction stroke, the charge will be compressed during the compression stroke. During the compression stroke, both the valve will remain closed. Only after that you can compress the charge, right? Reduce the volume, you will increase the pressure. Simple law. You can see the charge is compressed, and in case of the diagram you can see the pressure is being increased. After the pressure is increased, we will apply the spark in the engine with the help of spark plug. When we apply the spark, fuel plus air will start burning and it will release an energy. That energy will push the piston towards the downward side, and that will give us an expansion stroke. During that, heat is being supplied in the engine, and you can see the graph in which the heat is supplied. After the supplying of the heat, you can see the piston moving from the TDC to BDC. That is known as the power stroke, or we can also say expansion stroke, because expansion of gases does happen in the case of the power stroke. After completion of the power stroke, the last stroke is to exempt or to get out the gases from the engine, that is known as the exhaust stroke, in which the gases will be exempted from the exhaust valve with the help of opening the exhaust valve. So these were the four strokes that is commonly used in the four-stroke petrol engine, right? So this was a basic operation of the 4-stroke petrol engine. So in this video we saw about the pot timing diagram of the 2-stroke petrol engine, and also we saw about the working of the 4-stroke petrol engine. In the next video we will see about the 4-stroke petrol engine bar timing diagram, and also we will see about the further criteria that is required for designing and selection of the engine. Until then, thank you so much.